In this video, we're asked to write a method called matches that returns a count of the number of nodes in one tree that match the nodes in another tree. A match is defined as a pair of nodes that are in the same position in the two trees relative to their overall root that store the same data. So, actually, interesting thing is there is an error here where it underlines the nines and says that those are in the same position relative to with respect to the overall root. That's actually not true here. We should be looking at the twos because the two pathways down to here, you can see that the 3, 7, and 2 are both shared amongst the trees, and the 0's location is shared amongst the tree. The 8 position is not shared, and the 9's position is not shared amongst the tree because in tree 1 we have to traverse down the left and the right, but in tree 2 we traverse down the right and the left. They're exactly opposites. And it's actually mentioned right here in this line here. The next level of the tree has two matches storing 0 and 2. The two nodes store 9 at this level, but they are different positions in the tree. For some reason, these two 9s were accidentally highlighted. So that's an error there. But anyhow, let's get started with this. We're going to return an integer for the count of the nodes that match. And we're going to take in another tree. And let's see, we're going to return a private helper method, which will take an overall root, and then it'll take its other overall root, because that's the way we're going to traverse through these trees. So our private helper method is going to be of the type integer, and it's going to be matches. We're going to take an int tree node, R1, and another int tree node. I'm going to call it R2. Alright, so what happens if R1 or R2 is equal to null? Well, in that case, we have nothing to compare for the matches here, and we just want to return a 0. So, if R1 is equivalent to null, or R2 is equivalent to null, then we're just going to return 0. Okay. Now, in this case, we want to look at how many matches we get. So let's set up a sum variable. It's going to traverse down the left sides of both of the trees. So r1.left and r2.left. And then we're going to add matches that are found by traversing down the right sides of those trees. So r2.right, yeah. And then what do we want to do? Well, how do we know if we get a match? We get a match if the data value in R1 is equivalent to the data value in R2. And what do we want to do at that point? Well, we want to return that we found a match. So we're going to add 1 to the sum here, and we're going to return it. Otherwise, we know that we haven't had a match, so we want to keep looking for matches, so we're just going to return the sum. And that should be it for this video.